We've learned how to solve both single and multi-step equations, and we've also learned how to solve both single and multi-step inequalities. The next thing that we learned about with equations was equations with variables on both sides. That's where we're going with inequalities as well. So copy down your target for today. You should know how to solve equations with variables on both sides. So the inequalities are going to be the same way, except you have to remember if you multiply or divide by a negative, you must flip the sign. I'm not really going to teach you these examples. What I want you guys to do is actually solve the 4 examples that are in your notes on your own. You can share your answers with each other and your methods that you used, and then check your work and your answers with my video. After that, you're going to create a universal set of steps for solving an inequality with variables on both sides. So that's going to be part 2. So copy down the target, and then for part 1, just pause the video, solve these 4 examples. These are the first 2, and then press play to go over it. I'm going to just show my work and go over it quickly, so it's up to you to do the work on your own. So hopefully you've tried all 4 of the examples. Maybe you can compare it with any student that is in enrichment with you. If you are the only one, you can check it with me here. On both of these equations, remember that your work may look a little different than mine. There's often more than one way to solve an equation, and so your work might be slightly different. The important thing is our answers should match. So you should end up with y is greater than -4 for the first one, and n is less than or equal to 3 2/3, or you could say that as 11/3 for the second one, and you have your graphs right there. I didn't tell you to graph with the directions, you just had to solve, but you can add in your graphs if you would like. Check your work, make sure you have the correct solution. If you don't have the correct solution, go back and please correct your work. In both of these examples, we distributed first, and then we're getting our variables together. So in the second one, I actually had to combine like terms, and I can see that these ends cancel each other. And now I'm just left with this equation. And I had to get a common denominator to add those. On the first example, once you're at this step here, after combining like terms, you have to choose to take the variables to one side or the other. I always take the variables to the side where there is more. So I added 5y to both sides to make it a greater positive number over here. You could subtract y from both sides and get a -6y. You're still going to end up with the same answer. Check your work. Again, make corrections if needed. On the second 2, you might have been a little tripped up on this. Hopefully, they did look a little weird to you. You should distribute first, and then you want to get the variables together. So in both of these equations, when I add a value to both sides, my variables cancel. And I'm left with 2 inequalities like this. Again, maybe your steps were slightly different from mine. Maybe you subtracted 12 and subtracted 12 here, and then you would have 2 is greater than or equal to 0. Or maybe you subtracted 10 and subtracted 10 here, and you would have 2 is greater than or equal to 0 there, okay? Regardless of what your inequality actually says, here's what you need to make sure you do have. Your variables should cancel. And you should have an inequality that you have to ask yourself, is this true? Is 12 always greater than or equal to 10? Yes, it is. That is always true. So what does that tell you about your solutions? You should remember with equations, there were special cases, guys. These are your special cases. They exist for inequalities as well. So if something is always true, or if every number is a solution, we call that an identity, and that's all real numbers as your solution. If something is never true, then it's no solutions, that's a contradiction, and you're going to have no real numbers as a solution. Again, I didn't ask you to graph, but I wanted to show you these 2 graphs. So if every number is a solution, your graph would be the whole number line. I like to shade above so you really have no question on the fact that it is every single number. If it's no solutions, you're literally going to have nothing graphed, okay? We don't typically graph these, but if you wanted to use a graph to represent them, you could do this. So hopefully you have these 4 equations pretty good. What I want you to do for part 2 is I want you to kind of discuss what you did for each problem in the general sense. So don't be specific. And I want you to put together a list of steps that you could use to teach a new student how to solve any inequality with variables on both sides. So remember, what do you undo first? You know, if you see parentheses, is that the first step you want to handle? Make a general list. Don't be specific in saying, you know, I would add 5 to both sides, but maybe you want to say something about to isolate the variable. Brainstorm your ideas here, and then you can I'll show you my list of what students from the past years have come up with that I kind of organized together. So pause the video. If you have other students in enrichment with you, you can discuss this here in this section, or you can do this independently. Now that you've come up with your list of ideas, hopefully your list is going to have some of the stuff that I have here. Again, this is a collaborative list from the students in the past. So this is what they came up with if they were going to teach somebody how to solve an inequality with variables on both sides. Make sure you do have something in there about needing to flip the sign when you multiply by a negative. You definitely want to have that. And make sure you have your special cases as well, okay? So if it's always true, it's an identity. If it's never true, it's a contradiction. You're ready for your quick check.